Welcome back to Ben's Book Club. Today, we are diving into the book Rethinking Food and Agriculture 2020-2030. The core premise we're looking at today is a massive, systemic shock heading straight for one of the oldest human institutions on Earth. We're talking about the very real possibility that industrial animal agriculture is facing total economic collapse.
Just let that number sink in for a second. 50%. The independent think tank RethinkX predicts that the United States cattle herd will drop by half by the year 2030. Now, for anyone who's ever driven through the American Midwest or just, thought about the sheer massive scale of the global meat and dairy industry, that number creates a serious moment of cognitive dissonance, doesn't it? Half the herd, just gone, and within a single decade.
It's absolutely crucial to understand that this is not some argument rooted in an ethical plea for veganism or climate activism. No, this is a ruthless technological and economic disruption manifesto. The authors are taking the exact same economic modeling that we saw play out when digital cameras completely obliterated chemical film or when the automobile replaced the horse, and they're applying it to cows. It's simply a story of a faster, cheaper, vastly superior technology rendering an older system completely obsolete.
Okay, let's dive into this. Because to truly grasp the sheer scale of what is happening here, we have to zoom way, way out. 10,000 years ago, humans underwent what's called the first domestication. We took macroorganisms, entire whole plants and animals, and we slowly bred them over generations to suit our needs. But today, we're right in the middle of the second domestication. Instead of breeding these massive animals over years, we're now domesticating microorganisms, things like yeast and bacteria, right at the cellular level. We're actually programming them to do our bidding in a matter of days. It sounds totally like sci-fi, but it's already happening. The technology driving all of this is called precision fermentation. Think about the last time you visited a local microbrewery and saw those massive stainless steel vats brewing up beer. You actually already understand the basic concept. But instead of programming yeast to produce alcohol, scientists are engineering these microorganisms to brew specific, highly complex molecules. We're talking about the exact dairy proteins found in milk or the specific fats that give a steak its rich flavor. It's exactly the same process we have used to make human insulin for decades, just vastly scaled up and applied directly to our food system.
This precision fermentation unlocks a radically new model that they call food as software. In traditional agriculture, a cow is basically a biological factory, right? But it's a remarkably slow one. You can't exactly download a software update to a cow. But with this new paradigm, scientists identify a molecular blueprint. They upload it to a digital cloud cookbook, and then food engineers literally anywhere in the world can download that exact recipe and brew it locally. And just like the apps on your phone, these food products can be continuously iterated and improved. Version 1.0, 2.0, 3.0, getting cheaper and tastier with every single update.
Now, what's really interesting about this slide is the core reason why the cow is so incredibly vulnerable to this disruption. As a protein-producing machine, it is shockingly inefficient. Research cited in the report points out that a beef cow converts only about 3% of the protein it eats into edible human protein. 3%! The other 97% is just entirely lost to maintaining the animal's metabolism, growing bones, and generating body heat. When you're competing against a hyper-efficient microorganism brewing pure protein in a vat, well, that 97% waste margin is an absolute economic death sentence. And that massive inefficiency sets the stage for a staggering economic shift. Back in the year 2000, producing a single kilogram of these molecules via precision fermentation cost $1 million. $1 million bucks. But by 2019, that plummeted to just $100. The projection here is that as the technology scales up, these modern proteins are going to become 5 times cheaper than traditional animal proteins by 2030. They will eventually approach the cost of plain, everyday sugar. But, how does that actually bankrupt a massive global industry? The secret lies in this fascinating concept called unbundling the cow. You don't actually need to invent a perfectly textured lab-grown ribeye steak to destroy the cattle industry. You just need to replace the cheap, high-volume ingredients that keep their razor-thin profit margins afloat. Think about the whey protein in your post-workout energy bar, the milk powder sitting in your pantry, or the cheap ground beef in a late-night fast food taco. Once biofermented alternatives steal those specific ingredient markets, the underlying economics of raising the whole animal just completely fall apart.
So the crucial point is the feedback loop that gets triggered here. RethinkX calls this the economic death spiral. If alternative proteins capture even a tiny fraction of the market, say just the dairy ingredients, the traditional livestock industry loses volume. And when they lose volume, their massive industrial slaughterhouses and processing plants can't operate at full capacity anymore. That causes their processing costs per unit to absolutely soar. To cover those skyrocketing costs, they have to raise the price of traditional meat and milk, which of course only accelerates consumer defection over to the cheaper, fermented alternatives.
As this economic spiral accelerates, the environmental promises of this biomanufacturing shift are presented as downright utopian. Compared to traditional livestock, these modern fermentation alternatives are projected to be up to 100 times more land efficient, 25 times more feed efficient, and 10 times more water efficient. We're talking about a monumental plunge in direct greenhouse gas emissions and resource depletion.
And this brilliantly illustrates the sheer physical scale of the disruption. If the need for vast grazing pastures and endless fields of feed crops just vanishes, the report estimates that up to 80% of current livestock land could be freed up. To put that into perspective, we are talking about liberating a landmass equivalent to the entire Louisiana Purchase. That acreage could be returned to nature from massive rewilding projects, repurposed for giant solar and wind farms, or used as a massive carbon sink to actively help reverse climate change.
Beyond the environment, this fundamentally rewires global geopolitics. Right now, protein production is entirely tied to geography, arable land, and climate. But if food is brewed in bioreactors, production becomes completely decentralized. Nations that are currently vulnerable to supply chain shocks or climate-driven food shortages could suddenly just brew their own independent food supply right in localized urban fermentation hubs. They'd be completely insulated from weather shocks or trade disputes. It's a real game changer.
However, a disruption of this magnitude absolutely does not happen without severe casualties. While the tech and environmental sides look incredibly optimistic, the socioeconomic fallout would be devastating for the old system. The report projects that farmland values could plummet by 40 to 80%. Demand for feed crops like soy and corn will just crater, leading to massive job losses, stranded assets, and collapsing tax bases in rural farming communities. The entire logistics chain of shipping live animals and refrigerated feed would be completely hollowed out.
The vision is sweeping, right? And the economics really do make logical sense on paper. But we have to step back and ask a vital question. Is this hyper-aggressive timeline actually realistic? The authors predict industry collapse essentially by 2030, modeling their timeline on the steep exponential S-curves that we usually see in consumer electronics. But, as we know, biology and food systems carry their own unique physical and cultural friction.
When we look at the real world today, the U.S. cattle herd has certainly not collapsed by 50% yet. While precision fermentation is a very real, growing $5 billion market, it faces severe bottlenecks. Building the physical infrastructure, we're talking thousands of massive bioreactors, requires immense capital and time. Securing regulatory approvals from bodies like the FDA in the US or the EFSA in Europe, that is a notoriously slow, bureaucratic grind. And perhaps most importantly, there are massive psychological and cultural barriers for consumers when it comes to actually accepting lab-brewed proteins on their dinner plates.
Ultimately, this really boils down to a debate between direction and speed. Critics rightly point out that the specific 2030 target dates might be overly aggressive, delayed by physical scaling and that cultural friction we just talked about. But the fundamental thesis, the unstoppable direction toward cheaper, vastly more efficient biomanufacturing and the deep economic vulnerability of the cow, that remains incredibly compelling. The destination seems totally clear, even if the vehicle is hitting some speed bumps along the way.
As these incredibly cheap, perfectly engineered alternative proteins eventually take over our bulk ingredients, what actually happens to traditional meat? Will it completely disappear? Or will it simply become a rare, expensive luxury? Much like how vinyl records didn't go completely extinct, but rather became a niche premium experience in the age of Spotify. It completely changes how we will think about our dinner plates in the decades to come. Thanks for joining this explainer, and be sure to subscribe so you don't miss an episode.